Good afternoon or good morning, depending on when you watch this video. Welcome to a new remote teaching module of physics. For today's lesson, I'm going to explain why we do still remote teaching. And for tests, we are not sure. Yesterday, there was an update that the schools will be closed at least until the 28th of April. And that's the reason why you still have to be able to study some chapters from physics at your home. Of course, I'll try to inform you or teach you not new stuff from this clip. And if you have any questions, please use Magister or Teams to be able to ask questions. If we are having tests from the previous chapters, I don't know. We don't, but because we have made enough exercises with the previous chapter, we'll start with a new one, chapter 7, and that will probably be the last one. This is a little bit strange school year, so for now we start with a new chapter. And this is important. Magister will be the place for communication, so that means all your homework will be set in Magister. If you have any questions, most of the time I'll be online in Microsoft Teams. We'll discuss paragraph 7.1, and it starts off really easy. It's different types of radiation, and what a radiation exactly is. Well, when will be there something with radiation? Most of the time when something is radioactive. And that's the main goal for this chapter, learning new stuff about radioactivity. And a substance is radioactive when a substance spontaneously can decay. You can measure that using a Geiger-Müller counter. When a radioactive substance hits the measurement part, there will be a small potential difference. And because of the potential difference, there will be a current, and the current will be transformed into a sound. So each time a radioactive substance hits the measurements, you can count it as something like a radioactive material. And you can use a badge, of course. A badge, most of the time, it gets another color when you have when it receives some doses of radioactive material. The unit is becquerel. And it's abbreviated with BQ. And I will move myself a little bit down. Okay. In this case, we're going to look a little bit close to the electromagnetic spectrum. And the electromagnetic spectrum is actually started from over here to all the way around here. And from that electromagnetic spectrum, only this part is visible light. And magnified from this part. For this chapter, we'll be discussing most of the time this part. And what happens? Well, if you look closely, the wavelengths are shorter. And because the wavelengths are shorter, the speed of light increases and it gets more energy. I think up till now you've already know the infrared, the ultraviolet, and the visible light. The visible light are just the colors. Infrared is often used in a heating system, and the ultraviolet is when you get burned from the sun. Gamma rays and X-rays are often used in the hospitals or when you have been sick. An X-ray can be used to look into your body because your bones can absorb the X-rays while your muscles and your tissue, the X-rays pass through your body. And those are the three things that can happen with radiation. It can be able to pass through, it can be reflected, or it can be absorbed. And this is the last part of paragraph 7.1. These are three new, well, actually not all, I think frequency, it's the amount of, een aantal trillingen per seconde. And the speed of light is a set number. and it isn't meters per second, but it should be and now it's in kilometers per second. And lambda, that means the wavelength, and the wavelength is so actually the length of a wave, and a wave is just a top and a bottom. If you look closely to page 263 of your book, you can see what a wavelength actually means. If you think with when you read the first two pages of paragraph 7.1, you can answer the first 5 questions, and that's your homework for today's lesson.